Right, I think we'll get started then. So, hi everyone, and welcome to our talk about multi-layered automation. Before I start, I'd just like to say we will be sharing, obviously we're recording the session, and we will be sharing the pack as well. So some of these slides have quite a lot of detail on them. Don't worry about reading them. Obviously, we will be sharing them. We have also set up a Slido. So if you haven't used Slido before, it's just an online tracking of sort of comments, questions. So there's a QR code there and obviously a link. In the top right hand corner of most of the slides as well, there's the QR code as well. So if you have a question halfway through it and you think that you want to ask it, just put it on Slido. We'll spend a little time at the end going through the questions. Okay, so we'll introduce ourselves. I'm Joe, Principal Test Engineer at Answer, been at Answer 5 years. I've seen Answer grow from 1-2 people in QA to what we have now, which is around 15, including contractors. I myself have worked across retail, finance, and health projects, and implemented shift left multi automation strategies. Anand?
Hi, yeah, so I'm Anand, Senior Test Engineer with 5 years experience in manual and automation. I've also worked across finance, health and retail, and I'm also a certified Scrum Master. Joss?
Hiya, I'm Joss. I'm a test engineer with 3 years of experience in manual testing, previous role, and 2 years in automation here at Answer. I went through the Answer Automation Academy here, and I have a focus on CI and security testing.
Great. Okay, so I'll give you a bit of background of who are Answer, who are we. So we're a consultancy who specialises in digital transformation. We work across both private and public sectors. As you can see, Answer Digital was originally founded as UPCO, the Ultimate People Company, in 1998. And at that point, we offered development, agile coaching, project management, and we did that for a long time. But it was actually only until 2017 that we created our own in-house QA capability. Before that, we used to partner up with local testing companies, get contractors in. And then when we first started the QA capability, because we wanted to put quality at the heart of actually delivery, we pretty much utilized Selenium for all our automation. We testing through the front end using Java and .NET. And that's what we taught the candidates that came through our academy as well. So Anand, I believe Joss as well, probably learned Selenium when they came through our academies. But as development started to shift in 2018, we started to offer more native cloud solutions, microservices, single page applications. Very quickly realized that the strategy that we'd undertaken, sort of using Selenium, wasn't a good fit for that delivery model anymore, or that sort of solutions that we'd started creating. That's when we really started to think about how we could implement change quickly without losing quality. And this led us to adopting multi-layered automation, and that's what our talk's going to be on. So we'll get into what that is. And as you can see, we've sort of evolved over since 2017 up to now, and we still continue to evolve. And the test academies that the people that come to our test academies get trained differently every time as well. Anand?
Cool. Yep, so today we're going through common problems with traditional automation, what is multi-layered testing and how we use it. Or then we'll be looking at automation best practices. Then finally, we're looking at implementing continuous integration. So next slide, please, Joe. So first of all, let's look at common automation problems. So let's have a look at execution and implementation. So this is this is relating to writing tests which are way too long, and also tests that take too long to run. So the impact of this actually is you're sat around waiting for results for a longer time. This is affecting us deploying to environments, which holds us back from any other testing we have planned, for example, exploratory testing. And the overall effect on this is we're slowing down the delivery process. Thinking about, I guess, what I've just said around long tests, it leads me on to flakiness of tests. So when you're on a project, you can actually run tests, and sometimes they pass in the pipeline. Then with no code changes, suddenly they then fail. What this is actually telling us the resilience of the test. Our tests are not resilient enough. So then you're actually having to debug your tests. So you spend a long time debugging your tests to work out, is it actually a problem with the functionality, or is it actually a flaky test? And it is time consuming. So let's have a think about replacing all your manual tests. So you have a manual test on your project and you replace them all straight into an automation suite. It seems like a good concept, which would work in real life, but from my experience, it just doesn't. It tends to follow a concept called the ice cream cone pattern, which you can see here on the screen. This is top heavy on manual tests and UI tests. So UI tests traditionally do take longer to run, which takes me back to my previous point about slowing down delivery. When we think of implementing multi-layered automation, we want to move away from the ice cream cone pattern because this is bad practice. Next slide, please, Joe. So I just mentioned multi-layered automation. So what is it? So multi-layered automation is actually an approach where we're utilizing the concept of an automation pyramid, which you can see here with this diagram. So the pyramid is actually just a guideline. It shows the frequency of functional test types that appear in automation suite. So we're testing independently the resilience of the application. So you can see you've got your unit test, you've got your integration test, you've got the UI tests. And we do this because we want to hit all levels of the application to ensure the stability of what we're delivering. And the reason why the pyramid is bottom heavy is because unit tests and integration tests are much quicker to run compared to UI tests. And we do use layers because, for example, on a project, you wouldn't just have unit tests, you wouldn't just have integration tests, you wouldn't just have UI tests. You want the full test coverage. And by using this different layers, we're getting the full test coverage. Each one of these do come with their own benefits and challenges, but adopting a multi-layered automation helps us have a quicker time to deliver into market. Next slide, please, Joe. So why should we use multi-layered testing and the benefits and how it can actually improve your project? So let's first look at shift left and continuous delivery. This is testing early, catching issues early on in the life cycle. When doing this on a project, we're actually giving reassurance of what we're delivering is a good product, not only for the team, but also for the stakeholders. And another thing is by shifting left, we're actually increasing the code quality with changes being tested before code checking. So we have less chance of regression issues. And everyone on the team is actually following a coding standard. And by following a coding standard, what we're doing is producing clean code, which takes me back to the point about around regression. If you have a good coding standard and clean code, there's less chance of regression. And with less chance of regression issues, we're actually then able to create stable releases that we're confident in, and we are confident in what we're delivering. And when we have stable releases, we won't just be doing daily releases. We want to be able to do multiple releases, and we're getting a faster time to market by doing this. If we look at the increased return on investment, this is actually something which on a project gives us metrics of what we're doing is actually worthwhile. We're proving that following this concept and adopting it is worth doing, and we're actually getting buy-in from everyone. So we're getting buy-in from the customer, we're getting buy-in from your own team members, we're getting buy-in from stakeholders. So on my earlier slides, we spoke about the ice cream cone pattern. So before, like where the delivery takes a long time, by adopting multi-layered testing with, I say, the automation pyramid concept in mind, what we're doing is actually reducing execution time. And as I spoke about earlier, we're increasing frequency of releases. The bulk of the logic will be in the unit test integration tests, but we'll still have our UI test covering high importance end-to-end tests and edge cases. So I spoke earlier about, following a clean code, having a concept of best practices. So when we're actually writing our tests, we want them to be the truth, a source of truth. So we want everyone to understand them. That is our documentation. So when someone joins the project, we want them to be able to read the test and know what's going on from the start. And when we do adopt the concept of the automation pyramid, we use that as a guide, but not one size fits all. So depending on what project you're on, you've got different project requirements, your MVP might be different. But if we're actually keeping the test principles in mind, we can create our own test pyramid, which fits to your project. And following this approach, you're actually creating resilient tests, and you're building an automation suite which you're actually confident in. And I think that is over to you, Joe, now to walk through multi-layered automation in practice.
Yeah, cheers, Anand. Obviously, Anand's talked about multi-layered automation, but actually, what does that mean in practice? So I'm going to take us through how we actually implement. So I've taken a story here, which is a real story that's been implemented on one of our current projects. But how do we actually break this down and manage the work through into these layers? Hopefully, people have seen something like this before. Obviously, there's a wireframe on the left-hand side, which is just a table view, and the acceptance criteria. So we use Jira. We get stories. Generally, this is how all our features get passed to the development team and to the QA. So what's the first thing we need to do? We need to understand the architecture. So if the testers can understand the implementation details at this level, it can inform us about what type of test we need, so we can understand where the validation sits. Does it sit in the back end? Is there any front end validation that we need to test? Is the back end doing any transformers of data through mappers? What are the structure of the data models? It also helps break down the barrier between test and dev, because we're all talking the same language. We're all actually pulling in the same direction. And what you'll find is that each component within the sort of user journey is responsible for one thing. Obviously, the front end is responsible for presentation. The API is responsible for liaising with the database, and database is in charge of, obviously, data integrity. So as we start to look at actually, breaking these down, and can we test the responsibility of the layer in isolation from the others? The next thing we do is we look to do example mapping. I think if you was on the talk before on Rob and Alex's talk, they went into this a little bit more in detail than what we're going to do now. But generally, we use example mapping sessions to flesh out the acceptance criteria. I guess how many times have people been in backlog refinement sessions when potentially maybe not everybody is engaged, isn't potentially providing the value that it should be? Example mapping looks to sort of mitigate some of that. So it's limited who attends. Ideally, it's the amigos. So we're looking at the product owner, developer, tester. We also invite the UX designer. As you've seen, we're quite heavy on usability and creating wireframes. So we feel like they add value as well. And what we want to get out of this is a common understanding and a list of examples which elaborate the acceptance criteria. This is then turned into a test to assure that the correct feature has been developed. We generally time box this to 20 minutes per story. By adopting sort of example mapping, we're moving really towards acceptance test-driven development and starting to shift UAT to the left as well. So we're going to talk about, what are the assurance layers that have been implemented on the story that we looked at earlier. So we'll start at the unit test level. So generally, the developers write these, and it's included as part of the development work. Joss is going to talk about code coverage limits in his part as well. So we'll talk about how those are implemented on a project. Unit tests are looking to test the implementation of methods of components at a granular level. They are the foundation of a quality on a project. If you haven't got unit tests, it generally means that your tests are too expensive. They're too expensive to write, too expensive to run. So unit tests is where we want to do a lot of the testing itself. So understanding what unit tests the developers plan to write also ensures that we're not adding additional coverage in layers where we're wasting effort. So we're duplicating tests in the integration layer when actually they're better covered in the unit testing layer. So when we talked about code coverage limits as well, so Joss again is going to speak about that. We do recommend obviously that we have code coverage limits for unit tests. However, 100% is not attainable. We generally work on 70% code coverage limits. So that means if new development work, a new feature doesn't have 70% code coverage from unit tests, then it simply just can't be added to our code base. The next layer we're looking at is sort of backend integration tests. So these are looking at API tests, event-driven architecture. So if you're using something like Rabbit, Kafka, we set state and run async event tests through that. Serverless tests, so if you're using Lambdas, and contract tests as well. So if you're using microservices, how do we make sure that we can deploy microservices in isolation from each other, ensuring that contracts haven't been broken between them? At this layer, we're ensuring the service behaves as expected, given a predetermined request and DB state. Again, backend integration tests are generally very quick to run. The isolate service that we're testing and mock out any external services. The things that I generally think around backend integration, especially around API, is that we should be using a real database. But the way we do that is we spin it up in Docker. So we don't use a deployed database. We spin it up in Docker, seed it with data, and run the tests and then tear it down as we need. So what that allows us to do is run these in CI as well. So they are self-contained. We can also use packages like Web Application Factory. I believe Java also has the same. It allows the test to start the services in memory. So you're not having to run the services, run the tests, and then tear everything down. You can just start the tests, and if you set up Web Application Factory correctly or iHost Builder, you can actually start the services from the tests. Again, this means they're self-contained and can be run locally or in the pipeline. We also tried to use tools like snapshotters as well. So the way we try to speed up the implementation of backend integration tests is by using snapshotter. So generally, when we have a verbose sort of model that comes back as a response, you might spend quite a long time writing an assertion class, making sure everything's supposed to be where it is. Snapshotter takes all the heavy lifting of that, and what it does is it basically snapshots the response, saves it into a JSON file, which is then versioned and added to your code base. It's then used for any future runs as well to make sure that nothing's changed. And it really shouldn't change that much because the tests themselves are seeding the data. So you know the database is a known state, then hitting the service and then checking that the response is what you expect it to be. By doing this as well, we can also adopt data-driven testing in the back end. So when we looked at that screen before, so a list of projects, how can we ensure that the services, so this is where the business logic sits, behaves correctly for different types of users? And that's where we'll test that. So we'll try and hit it with different types of users, requesting different information from it, and make sure that the services behave as we would expect. The next layer we're looking at is UI integration tests. So these tests look to test the UI in isolation from the services, which sounds a bit strange really, but by testing the UI in isolation, we're able to check that the UI displays data correctly. It's in charge of presentation. We're going to make sure that it presents data correctly, but also reacts to user interactions, and we can check any JavaScript exceptions that are thrown as well. Modern testing tools such as Cypress, Playwright, Test Cafe have inbuilt service mocking. This is something that currently Selenium doesn't offer. So you'd have to use something like Makito or WireMock and spin up a separate server for your mocking. Whereas, like I said, JavaScript, generally the market-leading JavaScript frameworks do support this. These tests are faster than traditional UI tests. So when we talk about UI tests, we're generally talking about end-to-end tests. These, again, because they're just running the front end in isolation, and we are mocking all the service calls, so it's never hitting a real service or hitting a real database. They're pretty quick to run, and we don't have to deploy it anywhere. Again, we can run all these tests in the CI pipeline. By mocking the services, we're able to give the UI state, so we're able to check edge cases easier. We're able to check what happens if the database is empty and the response comes back empty. What happens if you have 100 that come back and does pagination work correctly? So we're able to test these things really, really easily without having to have database set up, having to go and find, realistic data, because we can just mock it all. We can also start implementing some of the non-functional tests here as well. So we can add automated accessibility testing using Cypress Axe or Pally. And we can also add some visual regression testing as well using something like AfterTools if the project so needs it. The final automation layer we add is end-to-end. So what we're looking to test when we talk about end-to-end. So these are what we would consider black box tests. They are testing on a deployed application. So, and they're looking to test business critical user flows. And this is why generally we try to write them in BDD using Gherkin. Strangely, what I've found when I've sort of spoken to clients and spoken to customers, this is what Anand was talking about in terms of the ice cream cone. These are normally tests that people start with. It's because you don't have to engage with developers, you don't have to engage with the integration teams. The QA teams can just go on and do this. However, it just leads to you trying to replace the manual regression pack with Selenium tests generally, because I generally think it's a quick win to try and reduce a 2-week manual regression cycle. But what happens is you end up with no confidence in the cycle. You end up running overnight smoke tests and being able to, oh, I've got a regression suite that runs over the weekend. Actually, the way, if you have multi-layered automation correct, you run all tests all the time. With end-to-end tests as well, it's also really difficult to isolate the issue because, again, the black box, and you're interacting with multiple components. So even if one test fails, it's very difficult to isolate. Did it fail because of the backend issue? Did it fail because the UI? Is the database set up correctly? And actually making these tests repeatable and scalable is really, really difficult. So you've got to deploy into a known state. You've got to put the database into a known state and have that be repeatable. So things like Terraform, Ansible allow us to do that. But again, it's not the easiest to do. The final layer that we look at for the story is exploratory tests. So we still look to run exploratory tests on any feature that we develop. Here we're looking to execute any tests that haven't been automated, but we're also looking to run usability testing and accessibility testing. So in the previous slide, we talked about automated accessibility testing and the tools around that. But actually, the automation tools for accessibility only cover around 30% of the standards. So, for instance, the tool can have a look to see if link text is missing on a particular element, but it can't tell you whether that link text is correct or a screen reader would be able to pick it up. So that is still done manually by us. We use the tools that the community use. So we use screen readers, we test keyboard navigation, so things like MBDA. All this is still done manually by us, and we rely on the knowledge of our expert testers to ensure the usability and the user experience is good for a feature before we sign it off. Okay, so I'm going to hand you over to Anand now, who's going to talk about adoption.
Yep. So thank you, Joe. So let's look at managing automation tasks. So the first one we've got there is definition of done. So usually, traditionally, when you start a project before your project starts, we think about the definition of done for every ticket. And really, automation should be at the forefront of that. We want automation tasks to be at the forefront of that. We want that to be thought about early on in the life cycle. And really, automation should not be seen as a technical debt. So I've been on projects before where we've created automation tasks where it's a technical debt, but then a feature comes in and that gets pushed forward because that's a higher priority. So automation should be part of the definition of done. It should be part of every ticket, and it should not be seen as technical debt. And what we want to be doing as well is keeping the quality bar high. So when we think of automation testing, dev tests, they should be seen as one. We want them to get merged in together. So on a project, that can mean dev test pair programming, which is good for collaboration, but we're actually making sure that code never gets merged into a stable branch without any tests. Thinking back to the definition of done, which I spoke about, when we actually create and estimate tickets, we want to be estimating the automation tasks as well. We don't just want to be estimating the dev tasks, because we're actually hiding the work that we're doing, and it's misinterpreting what it takes to get a feature deployable. From a project perspective, we're actually giving project managers not an accurate velocity when it comes to sprint planning. And everyone's responsibility is quality. So we want to feed back into the team, devs, project managers, that it is everyone's responsibility for quality. Next slide, please, Joe. So adopting automation is not an easy process, and having a change of mindset is one of the things we'll look at. So there's people challenges. where we want to move away from the traditional mindset where testing only happens at the end. We actually want to change a culture. So we want to change, we now ask everyone that we work with to be technical. So actually have an understanding of best coding practices, have a technical understanding of, like, for example, HTTP codes. And also as a tester, when you join a project, you actually want to understand the implementation details and the actual architecture of the system. The reason for that is we want to be able to understand where we can implement each layer of testing, which we spoke about part of the automation pyramid, and actually understanding DevOps practices as well. So by understanding DevOps practices as a tester, we're actually enabling a high quality gate. With a change of mindset, it's not only a tester's job to do this. So it should be, as I spoke about before, it should be a collaborative effort. So everyone is actually taking ownership. By adopting a multi-layer testing, we're asking people to take on more responsibility and work, but it is a team effort. And we're also asking, I guess, the business to change their mindset. We want people to buy into this methodology. And by adopting, I guess, a tester's mindset, we're actually improving quality in the life cycle earlier. Next slide, please, Joe. So let's move on to process challenges. So with multi-layered automation from the project get-go, we ideally want representation as early as possible from the test team. So early as a discovery phase. So we're ensuring that actually testing has been thought about, and we can start embedding this into like our automation test strategy, setting our objectives, our implementation plans. For us to actually adopt a multi-layered approach, we want to be working as one and have open channels of communication with the team. So we're not having disjoint teams. We want the team to be working together throughout the whole delivery process. Examples of this, I guess, from day-to-day project work is like some of the agile ceremonies. So backlog refinements. We're actually working alongside developers and others in the team to estimate tickets. Another example could be pair programming. So we're actually pair programming with the developers. As I spoke about earlier, we want to merge the coding together. So the code should have tests all the time. So actually, we're actually tackling tasks together with the same end goal of producing quality. So with the implementation of multi-layer testing, we want to be moving away from the traditional UAT and the delivery cycles. We want that to actually be a thing of a pass. We don't want to be waiting for long UAT cycles. What we want to be doing actually is delivering functionality frequently and often. This actually gives us a chance to get ahead of the curve. So finding issues early enough, resolving issues early enough, so we can actually redeploy and then before any project deadlines. Next slide, please, Joe. So the next slide, so this is technical challenges. So let's think about, first of all, the system is monolithic. So what I'm saying here is the system is tightly coupled. So it makes it very difficult to test. So an example is the UI may directly talk to the database. And this is actually an indicator of the poor architecture and shows no test representation from the early stages. And test is actually not being thought about. Then we have bought from a third party, which is black box. So which most of the time we don't actually have control of because it may be outsourced or the business, it depends on the business goals. But this actually causes problem from an automation perspective because we don't have access to the source code and it's hindering a test first approach and we're actually limited to what we can do. Another technical challenge is around environments and complex setup. So if we don't actually have a test environment or any test data, we can't really implement multi-layer testing. It's going to be a struggle because to implement multi-layer testing, we need to be able to have control of all the different areas of the system so we can implement all the different types of tests. And by having multiple environments to deploy to, we can actually constantly test new functionality whilst we say another environment has stable code base for customers. A big thing is test data. So when we think about test data, we think back to, say, the example mapping sessions and Amigo sessions, and we want to be able to test each different use case. So I spoke about the ice cream cone pattern before. So we want to switch that mindset and we want to think about the automation test period approach where I spoke about less cost, execution time is less, and we're having actual confidence in our automation suite. So next slide, please, Joe, actually. Yeah. So let's look at what can we do to make a to make a solution testable. So obviously there's many different design patterns and implementation patterns, but here are a few. So we have engaging with QA early. So this is actually essential. This is essential because we want all parties to actually be on the same page before any development has begun. Next thing we have is consistent design. So let's think about the consistent design of the API and think about actually engaging QA early. So we could actually set them consistent. We can actually set the consistent design there, and by having a consistent design, we're actually setting good practices from the start, which everyone should adhere to. And with consistent code, we're bringing quality. We spoke about the technical challenges about environments and data, but this is key to make a solution testable. It's enabling us to do any kind of automation and actually gives us full control of what we want to test. Then we have decoupling services and dependency mocking. So decoupling services is we want to test the services in actual isolation, which doesn't affect any other area. We're using this approach and it allows us to deploy services as and when needed. Then we have mocking. So by using dependency mocking, we don't have any external dependencies. Once again, like I said, with the decoupling services, it's actually allowing us to test in isolation. And it gives us an opportunity to actually test different use cases, which may not actually happen in a regular in a live environment. And I guess the final thing on testability is traceability. So some form of reporting is needed. We want this form of reporting so we can present back to stakeholders like evidence of our test execution, or actually help identify areas where there have been issues, and in future sprints or future projects we can look to improve in them areas. And that's everything on the delivery and design best practices. So over to Josh now, who will talk about implementing CI.
Thanks, Anand. So yeah, we talked in extensive detail about a multi-layered approach to testing. I think the final piece to the puzzle is the use of continuous integration. For me, the main difference between continuous integration and a traditional way of testing is around regression and non-functional testing. So first, to talk about regression, let's define it. Next slide, please. Testing the parts that weren't impacted by a change to see if they really weren't impacted. I think this really just shows how simple regression testing can be as an idea. I think in a lot of places that I've worked and a lot of places I've seen, it's turned into quite a huge beast that everyone dreads. As Joe mentioned earlier, often it can reach the point where it has to be run overnight. I think in traditional testing, at a certain point, both manually and automated, it reaches a point of diminishing returns with how we've traditionally done it. And when you look at how simple the definition is and really can be, if you shift your regression testing left and into a continuous integration flow, we can remove all the issues I just stated. It really doesn't have to be as big and as bad as we often make it. So next slide, please. Let's look at a traditional testing flow. Obviously, these can differ massively based on project or company. So let's just treat this as a generic example. I think the key thing for me here is that regression and non-functional testing is stuck right on at the end there. I think most people will agree this leads to a mentality of throwing work over the wall. So the devs completing their work and then saying, this is done, testers, you take over. Imagine we might have all been in positions where at the end of a release or however you're doing that, at the end of a sprint, with a day to go, with 2 days to go, you get a whole load of dev work. And I think it leads to a lot of problems and a lot of resentment. Testers feel like they don't have time to properly test the code. Devs resent bugs coming through. Testers resent that their work that they're meant to do is treated as something that's an annoyance, and often, you know, with time real press, some bugs will be allowed to go through. There'll be kind of a triage system around that. All in all, it's just not a great system. Also, with non-functional testing, you've got something like accessibility that's stuck on at the end, and it's super critical to certain people. and obviously not that noticeable to other people. And what I've seen before is that at the end, you find an accessibility issue and we're pressed for time. And because it doesn't affect, most of the customers, this will be kind of put down the line. We're going to do that later. And obviously to some users, that can be absolutely detrimental. So next, we'll look at the CI testing flow. Great. So the key thing to notice on this is that regression and non-functional testing has been moved right into the development process rather than being something that's tacked on at the end. Quite often in this kind of a flow, tests are run on every push, so really regularly. They're part of the actual development flow. Interestingly, often in this way of working, testers aren't actually involved when a bug comes up from this regression and non-functional testing that happens as part of the development process. If the output is easy to understand and to debug, then a developer will often push changes, create a PR, push changes, realize that there's an issue, go and fix it themselves, whether that's non-functional or general testing, and then go through that flow again. Often the tests in this case are set so developers cannot merge if the requirements aren't met, whatever requirements those are. We're going to talk about code quality and things later on, but that stops developers or anybody else being able to make the decision that X is not important this time, which can be quite useful. And obviously issues can be caught early, and this is when they're the cheapest to fix. And it also brings developers to the testing mindset. If they're constantly looking at the tests, if something fails, they're going to understand how the tests work, and they're also going to understand the value. So next slide, please. So I've just mentioned some benefits there, but let's just drill down a little bit into more of the benefits. So constant regression and non-functional testing, I kind of mentioned that, but seeing visible results and failures all the time is so key. The second one is a team who's very aware and engaged in the testing process. As I mentioned before, it's not something that's tacked on at the end. It's not something that can be scrapped for time. It's something that all the team need to think about and be responsible for. And then finally, one that I haven't really mentioned much is manageable and high quality test suite. As the test suite gets used consistently, it cannot be flaky. If a test is failing 1 in 4 times erroneously, this will be incredibly noticeable in CI, because quite often there will be 10, 15 commits in a PR. So we all have seen that fail multiple times in one PR. And then also time-wise, you have to make sure that these tests can't run overnight. They can't run longer than 10 minutes probably. And all the teams should be responsible for managing this and bringing up issues when things are running longer. Next slide, please. So we've talked a lot about the theory of CI, but I wanted to show you a realistic example that we're currently using on an open source medical project. Here we have a diagram just like the last one we saw, but we've broken the testing down into its component parts. Obviously, within the quality control continuous integration testing, you have an actual test step. This is to run integration tests and unit tests. We also have security. In this case, we have dependency scanning. So it's going to look through all the packages that we've brought in and make sure there's no CVEs on them and they're not vulnerable to attack. We also have secret scanning. So something that can happen fairly often is a developer is working on a piece of code, usually early on. They hard code a key or hard code some secret just to test, and then it can slip through. This should look for patterns that look like API keys, any kind of keys, and let us know if it thinks there's an issue. And if there is genuinely an issue, we can regenerate this key. We have SAST, which is static application security testing. This is security testing that's going to run without running the actual application. So it's going to look through the code again for patterns that often lead to vulnerable code and let us know about that. We use Sonar Scanner or Sonar Cloud or Sonar Cube, it's also called. That does our security testing in that sense, but it also does our code quality that Joe mentioned earlier. So it's also going to look for code smells, which are reported by the IDEs, so just bad coding practices. It's also going to look for code coverage. So we set, in our case on this one, 70% code coverage. So every little bit of new code needs 70% code coverage from the unit tests, and also looks for duplications, just general code quality. Next up, we have container scanning. Our code on this project gets bundled into containers every night. Those containers get scanned to make sure the base image doesn't have any vulnerabilities to start with, and then make sure that anything that we add on top of it also doesn't have vulnerabilities, so we're not handing out vulnerable containers to users. And finally, seeing as this is an open source project, we have license scanning. So in this case, we are running under an Apache 2 license, which means that we need to make sure every package that we bring in is equally as permissible or more permissible. So we've automated this. It will catch if anything is less permissible than Apache 2, and it will tell us, and we have flows for approving this, for seeing if it'll work, basically. We also have headers that we have to put on every file. Again, just another thing to do with us being open source. This will automatically scan every file and turn what is a terrible job of developers and testers or whatever, having to check every file that's being added in a PR and make sure it just has a little bit of writing at the top. This really simply just stops the devs in their tracks and says, this is the file, go update it. Yeah, so that's a realistic CI pipeline example. We've talked about a lot today, I'm aware, so I'm going to pass you back to Joe to sum up the key points to some easy takeaways for how to implement a multi-layered automation strategy. And then, of course, we've got the questions shortly after.
Yeah, cool. Cheers, Joss. So some of the key takeaways. So, we want to write software with testability in mind. We must design software to make it testable. It's not good enough to just bolt on quality at the end. We should be, designing with quality in mind. It allows us then to implement the multi-layered automation to get the best return on investment when you're starting to undertake automation. We should avoid the ice cream cone anti-pattern. So we should look to only add tests in the layer where they are most valuable. We shouldn't be testing the back end through the front end, for instance. We should be looking to decouple where we can. So we should learn to break down stories into their components using example mapping or other refinement tools such as Amigos or backlog refinement. You need to start thinking a little bit differently about features and how they're implemented, and getting used to the technologies and the terminology that devs use as well. And then we must employ CI to help enforce good behaviors, because quality isn't something that is optional. It should be enforced, and CI helps us enforce that. Thanks for listening to us. I'm going to go on to a couple of questions now. So we've had, let me just open up the phone. One saying, how do you ensure mock data and services stays in sync with real data services? So I'll take this one. So when we talk about the backend, so we talked about Snapshotter. So that's one tool that allows us to quickly add those mocks, those JSON files, into our front end to ensure that actually the responses that we're getting from a known database then are reflected in the front end. We also do processes as well. So this is where Anand was talking about shift left and the testers being involved. Every new feature goes through and we review it as well. So we'll be able to say, this is going to break certain tests, this is going to affect this. And we actually estimate all the automation work as part of a new feature. We don't hide that. So that's how we keep it in sync, really. The next one is around best practice to report test automation to show to stakeholders. Anand, Joss, do you want to take that one?
Yeah, I can.
Yeah.
So can you repeat the question, Joe, again? Sorry.
What are the best practices around reporting test automation to show to stakeholders?
So what we do, well, part of what I've done in the past is for integration test and for UI test, we have a reporting tool. We use that, and that displays, I guess, past tests, test coverage, and you can put that onto dashboard as well for stakeholders. Because when you go through a test, you don't want stakeholders don't want to be looking at every single individual test, so we create dashboards for that as well.
Yeah. So yeah, one of the things I guess we do, because we're obviously, we don't build products, we build for clients, and they want to know in terms of test coverage. So we also use things like extent reports, mock awesome, that generate HTML reports. But actually fairly recent, we're looking at report portal, which is you can deploy into AWS or Azure, and it's actually a nice UI where all the results go to, and then you're not pushing results out to stakeholders. Stakeholders are actively engaged and pulling information to them as well. So we're looking at that. And the final question, I guess it's pertinent to Joss really. Do you split your test suites when running in CI?
Do we split our test suites? Is that in the sense of
yeah, I guess
depending on the work that's done, do we only run a subset of tests?
Yeah, I think so.
So you might have had more experiences with this, Joe. I've only been on 2 projects that have used it, but in my experience, we've never split the tests out. We've always tried to, it comes back to that, keeping it as quick and manageable as possible. In my experience, if you're doing that, you've broken down all the tests to the correct layers so they run quick. You haven't got any of these huge tests that take minutes to run. If you do that, I've found that you can just run all of the tests. In the realistic example I gave you there, for example, I think our entire test suite takes 4 minutes to run, maybe, and that's over 500 tests. So yeah, I'm sure there's some situations where that's not possible and perhaps you need to split it. I've personally never done that, but yeah, I've found that we've not needed to on the projects I've worked on.
Yeah, I'm a firm believer of this, that if you implement the layers correctly, you should be continually testing all the time. We've been on projects before where they have you know, a smoke test that runs on every CI, and then they run an overnight regression suite. Really, if you take the approach to automation correctly and, you know, have integration tests, UI integration tests, and only a subset of end-to-end tests, you should be able to run everything all the time. So you're continually testing. And let's have a look. We've got a couple more. Probably one for Joss again. Do you always run the quality control step in the pipeline, even for small changes?
It's not even just for small changes, it's for every push in that realistic instance. So yeah, a developer, as soon as they create a PR in our case, then every single push to that, so no matter what they've done, if they've changed one letter, it will run entirely. But as I said, the whole suite takes 5 minutes to run all those tests all in one go. So yeah.
Yeah, you can also add like Git hooks or Husky or something to enforce people to run it locally. We generally don't do that because devs get annoyed, but you can force people to run stuff locally as well.
You know what, there's actually, sorry, I've got one, recently I changed that example where Dependabot, I don't know if people have used Dependabot, was doing updates to packages, so it automatically updates your packages, and it was running like security scans and everything for those, which was taking a long time to get them to merge. So in that case, I did take out a few of the tests, just a few of the really long running CodeQL security scanning tests. So there is instances, but I've never taken the tests out of anywhere, like the regression tests. I'd only think about probably removing unneeded non-functional tests.
Okay, great. And then any recommended tools for end-to-end testing of mobile apps? So yeah, we've had a look. Obviously, Appium is probably what most people sort of default. So we've had a look at that. I wasn't a massive fan. Just a case of worked great for Android, but didn't work very well for iOS. So actually, we've started to have a look at you know, Xcode and actually things that are, you know, aligned with the dev code that's been done. And there's things like Detox for if you're using React as well. So I recommend using those over something like Appium. Again, Appium is of the same ilk as Selenium, where even if you get an issue, it's quite difficult to identify where it is sometimes. So yeah, it's still, I think, an area that automation testing tools need to improve, and doing really great with sort of single page applications, and we're starting to catch up on non-functional. So like I think Rob said before on another talk, you know, we used to use JMeter. We don't use JMeter anymore. We use a tool called K6 because it aligns better with CI practices and code reviews and things like that. So those tools are really, really sort of catching up with dev tools. I think in mobile we're still lacking behind in sort of test automation tools, to be honest. Okay. Another question probably for you, just how important is it for test running time? 5 minutes or an hour doesn't make much difference because it's happening behind the curtains.
So how important is keeping that time low? Is that what?
Yeah, correct.
Yeah, very important. You are right, it is happening behind the curtains, and sometimes dev will be pushing really regularly and not even checking the test in some cases, not till like the end, till they're happy. But then what you don't want is for them to be ready to merge the pull request and then have to wait an hour, which would be very frustrating anyway. And then quite often, I think if you're in that situation, you'd wait an hour and then someone else will have pushed their code and you'd have to rebase, and then that hour would run again. So I think it is really key to, I really wouldn't want those tests to run for over 10 minutes, even 10 minutes, I think is on the line.
I think so. I think from our point of view, we may say, oh, what does it matter between 5 minutes or an hour? If you spoke to a developer, they'd be saying you cannot have tests running for an hour on my code. This is where we really speak to them, because like Josh said, what will happen is somebody else will merge in and they'll go, right, we'll start from the start again, and that's another hour. So you can end up wasting half a day just trying to merge your code in.
I think it's a real fine balance between code coverage and not. It's a real fine balance between your test not winding everybody up, and what I think people will have found before is if your tests take too long to run, you will almost lose buy-in from developers as well and from the business. They will again start to be seen as a nuisance rather than something that is really helpful for everybody. So I think that's the kind of line that you've got to walk.
Yeah. Okay, great. So the final thing, thank you everyone for joining us. One of the things that we're doing at Answer on the October 7th is we're taking part in Boycott Your Bed. It used to be called Bite Night, and it's to raise money for Action for Children. So it's for looking out for children that are potentially being made homeless, potentially haven't got any people to look out for them. So we'll be sleeping out in the streets in Leeds for a night in the cold. If you can give anything, that'd be fantastic. There's a QR code in the bottom. But yeah, really good cause. So if anybody would like to help out, that'd be great. Thanks for listening to us. If you want a question answering, or if you feel like we haven't answered some of your questions that you wanted to ask, or you need a bit more information, feel free to reach out to us on LinkedIn or send us an email. Obviously, be sharing this pack, and I'll also share our LinkedIn handles as well, so people can add us on that. So thanks everyone for your time, and I'll stop the recording there.
Thank you.